All right, so we'll just wait 2 more minutes for the others. Um, So while waiting for the others, do you guys have question or clarification so far? All right. So are you guys there already? Okay then. So let us now continue our discussion. So if we have addition, we also have subtraction. Okay. So let me just discuss this one. I guess no need for this one. All right. So this one is very straightforward. So 1 minus 1 is of course 0. And 1 minus so 1 minus 0 is of course 1. And then 0 minus 1 is 11. Okay, so you guys will figure out soon why do we have 11 in here. All right, so for now, let's have this example. So 1 minus 1. Oops, where is my snipping tool? All right, so from here we have 1 minus 1, which is of course 0. And then 0 minus 1 is cannot be. All right, so the thing that you need to do is of course borrow on your neighbor. Okay, so your 1 here will become 0, and then your uh, 0 here will become 11. Oops. All right, so that's how we borrow. Okay, so your 0 will become 11. Or in other words, this one will become, yeah, will become, no, sorry. This one will become 10. All right, this one will become 10, not 11. All right, and then from there, this 10 will be deducted by 1. So as you guys may all know, so 10 is being represented by 2. All right, so less 1 is of course 1. All right, and then we have here 0 minus 1 is again not or cannot be. So we have to borrow again on your neighbor onto the next number. So this 1 will become 0. Okay, and then this 0 will become 10. And then 10 minus 1 is of course 1. Okay, and 0 minus 0 is 0. 1 minus 1 is 0. And then 1 minus 0 is 1. All right. So were you guys able to get the logic on this one? So if you're going to borrow, okay, on a binary, okay, so instead of getting 1 only, you're going to get 2 instead, okay, which is being represented by 10. Okay. So are we clear so far? Or need more example? All right, so I'm glad that you guys were able to get this one, especially for Miss Jello and Miss Rubian. And for Mr. Jeremiah. So I like that answer, you know. I really like Anna's answers instead of just saying yes sir, because I have other students just keep on saying yes sir even though he or she didn't really understand anything. All right, so don't you guys or don't you worry, Mr. Jeremiah, we'll be having more example. Okay, so this is just for example number 1. So we have here example 1, 2, 3, and 4. So let us see this one. So we will only answer 2 questions. So let's answer number 2. So I'll leave this part to you guys. So analyze this number 1. This is already answered. So from here, so 1 minus 1 is 0. 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 1 is 0. And then 1 minus 0 is 1. Dot. 1 minus 0 is 1. 1, 1. This number 2 is nonsense. Anyway, but this is the answer for number 2. Okay? So I hope that you guys were able to get this one. So are we clear with number 2? Hello? All right. Okay, so I will erase this one now so that we can proceed to the harder example. Okay? Much more difficult. So just choose number 4. All right, so let's answer number 4. So we have here 0 minus 1 is cannot be. So we have to borrow, okay, to the neighbor. So number 1 will become 0, but this 0 will become 10. Right? So 10 minus 1 is 1. Right? And 0 minus 1 is cannot be, so we have to borrow. But then this 0 doesn't have anything, so this 0 will have to borrow for us to be able to borrow. Okay? So let me just erase this one. So white is much more better. So this 1 will become 0. And then this 0 will become 10. So from there, we now have a value of 10. So we can now borrow from this one. So 10 will become 1. And then this 0 will become 10. So 10 minus 1 is 1. And then 1 minus 1 is 0. And then from here, we have 0 minus 1 cannot be, so we have to borrow again. But then again, we cannot borrow to our neighbor since he doesn't have anything. So we have to borrow to his neighbor for us to be able to borrow again. Okay, so this 1 will become 0. This 0 will become 10. And now he has now money, so we can now borrow. So this 10 will become 1. And then this 0, 0 will become 10. So 10 minus 1 is 1. And then decimal right here. Then we still have 1 right here. So 1 minus 0 is 1. So bring it down. 0 minus 1 is cannot be. So we have to borrow. But then again, his neighbor doesn't have anything. So he has to borrow first for us to be able to borrow. So this 1 will become 0. This 0 will become 10. So now that he has now money, then we can now borrow from him. So 10 will become 1. 0 will become 10. 10 minus 1 is 1. 1 minus 0 is 1. 0 minus 1 is again cannot be, so we have to borrow. So 1 will become 0. 0 will become 10. And then 10 will become 1. Okay, so this 0 will become 10. So 10 minus 1 is 1. 1 minus 1 is 0. And 0 minus 1, this cannot be, so we have to borrow. So this 0 will become 10, but before that, this one has to borrow first. So this 1 will become 0, and then this 0 will become 10. And then from here, we now have a value of 10, so we can now borrow. So this 10 will become 1, and then this 0 will become 10. So 10 minus 1 is equal to 0. 1 minus 0 is 1. And yeah, that's it. So were you guys able to follow or no? So maybe no, since our solution is quite messy. All right, so good for you, Mistress Guerra. So I'm hoping that the others were also able to follow. So my only advice is when it comes to subtraction, if it's 0, if you're going to borrow to its neighbor, of course, this 1 will become 0, and then this 0 will become 10. All right, and if you're going to borrow, let's say to 10, this one is 0, this 10 will become 1. All right, and this 0 again, of course, will become 10. All right, so that's how it will become if you're going to borrow from 0, it will become 10. And then if someone borrowed from 10, it will become 1. Okay. So yeah, that's it for the 1, 2, and 4. So I'll leave this number 3 to you guys as your practice exercise. All right? And you can search more on the internet for more examples, especially for subtraction, if you want to learn more on how to subtract a binary. All right? So is there still someone who's quite confused when it comes to subtraction? All right, so I'll take that as a none. Okay then, so we have here octal addition. Okay, so in octal, so it worked the same with our normal addition. However, as you guys may all know, we don't have 8 and 9 when it comes to octal. So later on, we're going to have a short discussion on how we handle 8 and 9. So from here, we have 2 plus 3 is 5, so no problem. So the same 1 plus 5 is 6. 65 base 3. Okay, so no problem when it comes to letter A. But for letter B, so 1 plus 7 is actually 8. Okay, and then if you're going to recall, our octal to decimal, it's to be the other way around. So decimal first, and then octal. So 0 to 7, okay, is the same with octal. So 0 to 7. However, once we reach 8, 9, and 10, let's say 8, 9, 10 for now, okay, the next one for the octal is already 10, 11, and then 12. So as you guys can see, plus 2, and then plus 2. This one is until 17. Okay. For the 18 and above is correct. 11, 11, 12 plus 2 plus 2 plus 2. 8, 9, 10, 8, 9, 10, 11, 12, 13, 14. Sorry. This one is up to 15 only. 15. Okay, that is why it's up to 17 only right here. And then the next one is 16. And then this one now is plus 4, which is 20. All right. So from here, okay, 1 plus 7, in decimal it's 8, but in octal, it is equal to 10. So that is why you have to put here 10, which is, of course, raised to 1 and then bring down 0. And 3 plus 2 plus 1 is 6. Okay, so that is why 27 plus 31, in octal, it's equal to 60. All right. So were you guys able to understand this one? Letter B. Hello? You guys still there? Hello? Yoo-hoo! Okay. Kala ko natulog na kayo eh. Alright, so that's how we solve the addition when it comes to octal. Okay, so we don't have 8 and 9, 18 and 19, 28 and 29, and so on and so forth. Alright, so when it comes to 8, it's equal to 10. Alright, so let's answer this one. So what we have here, we have 6.7 and then 45.6. Okay, both of them is base 8. So 7 plus 6 is 13, wherein 13 is not already part of the octal. So 13 plus 2 is 15. There you go. So carry 1. 6 plus 5 is 11 plus 1 is 12. Okay. So 12 is already 14 in decimal, or in octal rather. And then 4 plus 1 is 5. So in here, 6.7 plus 45.6 is 54.5 base 8. Okay, so if you're confused about this one, 7 plus 6 is 15, you can always go back with our table. Okay, right here. Okay. So we have 0 to 7 the same, but 8 to 15 is plus 2. And then 16 to 23 is plus 4. Right? So the answer for letter C is 54.5 base 8. Okay? So were you guys able to get this one? So if it's 24, then that's already plus 6. No, no, no. So 1 to 7 is, sorry, 0 to 7, decimal to octal, 0 to 7 is the same. Okay? But when it comes to 8 to 17, 8 to 15, sorry, 8 to 15, this one is already plus 2. So this one is 10 to 17. For 16 to 23, am I correct? 8, 15, 23, yeah. 8 to 23 is plus 4. Oops. So from here, it's 20 to 27. And then 24 to 31, so just plus 7. And then right here, it's now plus 6. Okay, so starting from plus 2, next one is plus 4, the next one is plus 6, and then plus 8. Okay, so right here, it's already 30. And then 31 plus 6 is 37. Okay, so it actually has a pattern. So 0 to 7, so 0, 10, 20, 30, and so on and so forth. And then we have here for the last one, we have 7, we have 17, we have 27, we have 37. Okay. Are you taking a screenshot, Miss Diana? Because she said wait, so maybe she's taking a screenshot so that she can have a copy. Well, there's a lot of copy, especially on the internet. That one is much more complete, decimal to octal representation. No. You're not going to times to it. Just add. Okay. So from here, it's the same, plus 0. From here is 7 to, yeah. So 7 to 17. And then 10 to 17, sorry. 10 to 17 is plus 2. 20 to 27 is plus 4. 30 to 37 is plus 6. Okay, so those plus 6 will be added with our decimal, okay, not here. So, for example, this one, how did we get 30? So 24 plus 6 is 30. All right, so enough with that. Let us now finish this one. Where are we now? Octal addition, all right? So yeah, that's it for the octal addition. So I will not answer D and E anymore since you don't have enough time anymore. So we'll just proceed with the next one, which is hexadecimal addition. Okay. So in here, this one is the same method, but this one doesn't have 16, 17, 18, and 19. Right? Yeah, it has, but that's a different number one. So we'll discuss that one later on. But for now, let's answer letter A. So 4 plus 6 is 10. And in hexadecimal, 10 is letter A. All right? And then 2 plus 7 is 9. So this one has a result of 9. And then we have here 7 plus 9 is 16. However, so let's have a decimal to hexadecimal. Okay. So 0 to 9 is the same with hexadecimal. Okay. And then 10 to 15, this is now the A to F. Right? But once you reach 16 to 25, okay, so this one now is being represented by 10. Okay. 10, oops, 15 to F. Let's just arrange that one. Yeah, there you go. So 16 is 10 up to, so this one is plus 9. So 10 to 19. So this one also has a pattern. So 0 to 9, 10 to 19, and then from A to F, we also have 1A. And then the next one here is, of course, 26 to 6, 32. 26 to 32. And then this one is 1A to 1F. All right. So until this part for now, okay, until 1F. I guess this one is already enough for all of the things that you're going to need when it comes to solving hexadecimal addition. So like, for example, this one, so 7 plus 9 is 16. So we have here, so 7 plus 9 is 16. So 16 is equal to 10. All right, so carry 1, bring down 0. And then we have here F and then E. Okay, so if you're going to add all of those, F is equal to 15, and then E is 14, and then plus 1. So as you guys can see, this one is equal to 30. And 30 right here is equal to, so 31 is 1e. I guess this one is up to 33. 1a, 1b, 1c, 1d, 1e, 1f. 6, 26, 27, 28, 29, 32. Ah, yeah, sorry. So this one is 33, okay? Not 32. Okay. So of course, the 1e is 32. A, B, C, D. 1d is 31. 1c is 30, and so on and so forth. It's inside or between 26 to 33, and then 1a to 1f. All right. So that is why right here, 15 is F, and then 14 is letter E, and then 1 is this one. Okay, so just add all of those, you'll get 30. Wherein 30 is equal to, what is it, 1C? 26 A, B, C, D, E. 82. Hmm. Is there something wrong with my arrangement? So 7, 16 is 9, it's 25. And then we have here 26, 27, 28, 29, 30, 31. Ah, sorry. Why did I add 2? So this one was supposedly 31. Can you guys still follow? So my bad for that one, alright? So 26 to 31 is 1F. So very good, Mr. Esguera, okay, for realizing that one. And then, yeah. So right here, we have here uh, 30 is equal to 1E. Okay, and then 29 is 1D, 28 is 1C. And then from here, as you guys can see, we have here 30, which is equal to 1. So that's how we've got 1. All right. So were you guys able to follow? No? Are we clear so far? I guess not. All right. So if you guys, so we're finding 7 plus 9. So 7 plus 9 is 16. So 16 is 10 right here. So carry 1, bring down 0. Okay, so this is our remainder one. Oops. So we now only have 10 minutes. So how many slides remaining? So 20. Anyway, so we're going to have part 6 just for us to finish this module 4. Okay, so was I able to answer your question, Miss Tulay? 7 plus 9 is 10, or 7 plus 9 is 16, right, in decimal. But in hexadecimal, it's 10. So carry 1, bring down 0. Hello, Miss Lulay? Are you still there? All right. Okay then, so let us now proceed to the next one. Okay, so let us answer letters. All right, so let me just erase this one so that we can still have this reference. So we have 19.8, 19.8, and then AF9. So both of them is hexadecimal. So 9 plus 8 is 17, where in 17 right here is 11. So carry 1, bring down 1. And then 9 plus 1 is 10. 10 plus F is 25, wherein 25 right here is 19. So carry 1, bring down 9. And then A is 10, plus 1 is 12. So 12 right here is A, B, C. So C9, that 1. So were you guys able to follow this one? Hello? Please let me ask someone. Miss Balondo.
Sir?
So were you able to follow this one, this example, 19.8 base 16 plus AF.9 base 16 is equal to C9.1?
Sir, opo.
Yes, F is equal to 15, Miss Dulay. So, all right then. Very good, Miss Balando, if you guys, if you were really able to follow this one. Okay. So for Miss Mabanag, so she said that maybe she's quite confused. So don't you worry. Okay, so we have a lot of examples on the internet wherein you can find and how to add hexadecimal, how to add octal, and so on and so forth. Okay. And we even have a lot of sample problems here. So I would like you guys to answer those. Okay, so this will serve as your practice activity. Okay, so just send me a message wherein you can consult me anytime. Wherein, sir, I would like you to check my activity or practice activity regarding with hexadecimal, regarding with hexadecimal, and so on and so forth. Okay, so that is why uh, I am just here. Okay, willing to help you guys. All right. So do you guys have any other concerns so far? Aside from you didn't understand it fully. Any other questions or concerns before we proceed to the next one? All right, so an answer coming from Miss Tulay. All right, so let's now move on to the next one. So multiplication of binary numbers. So this is the only binary, say, operation that I will not explain anymore since this one is very straightforward. Okay, so this one is the same with our mathematics. So 0 times 1 1 1 1 0 1 is of course everything is 0. 1 times 1 1 1 0 0 1. So this is like copy everything if it's 1, okay, which is now this one, and then move it one step right here until you reach the last one. Okay, and then from here just perform addition. Okay, so just like the binary addition. Okay, so that's how we've got those results. So 0 plus 1 is 1, still 1. 1 plus 1 is 0, carry 1. So 1 plus 1 is 0, and then we'll carry 1. So 1 plus 1 plus 1 is 11. So carry 1, bring down 1. And then, of course, bring down 1 plus 0 is 1, and then 1, which is 1. All right? So multiplication of binary numbers is very straightforward. So all you need to do is multiply it and then perform addition. Okay, so there you go. There are the other examples. And sign binary numbers is a representation wherein, like for example, how do we represent positive 9 in binary numbers? So it's actually being represented by 0, okay? And if we have negative, it's being represented by 1. All right, but this is just the idea part. Okay, this is the part wherein they're saying that how about we just uh, put or change the highest significant bit into 0 if it's positive and then 1 if it's negative. Okay, so we have a process for this one wherein we'll be able to get the negative or the negative negative sign of a certain decimal into binary. Okay, so it is with the use of two's complement. Okay, so what is this two's complement? So when we see two's complement, your 0 will become 1 and your 1 will become 0. But before that, of course, we have a process. Okay, we have steps to do. Like, for example, this negative 9 became this one, or this is the representation of negative 9. 1, 1, 1, 1, 0, 1, 1, 1. So how did we get that one? So later on, I will explain how did we get that one. And we have here negative 13, 1, 1, 1, 1, 0, 0, 1, 1. And the negative 6 is 1, 1, 1, 1, 1, 0, 1, 0. All right. So enough with that. Let's now proceed to the example on how to derive two's complement. But then again, I just saw that we don't have enough time anymore. So we will just continue the rest on the part 6. So don't you guys worry, that will be the last part, okay, of this Zoom meeting for the module 4. Okay? So we will be able to finish everything now on the part 6. So goodbye for now and see you guys later on.